All right, welcome back. A new unit for 2 weeks to end the quarter. And we're still going to talk about quadratic equations, but we're not going to use the term equations anymore. We're going to call them now functions. So we're changing to function notation, and you should remember that from what we did in the past. And when we have functions, what we like to be able to do with them is graph them. And if we have a quadratic function in standard form, like ax squared plus bx plus c, it is challenging to graph that. It's not impossible, but it's challenging to graph that. And so what we're going to do is we are going to need to be able to convert the standard form of a quadratic function to what's called vertex form. And I don't say anywhere on here what the vertex is. All right, let's zoom into this little graph and I'll tell you what the vertex is. The vertex of a quadratic function when it's graphed is the point where the graph changes direction, essentially. So if you look at each one of these, like this one right here, we have a point right there where it changes direction. This one right here. So all these little black points are the vertex of these different quadratic functions. Okay, so essentially it's splitting the graph exactly in half from left to right. So, and that's kind of another cool thing that we are going to talk about. It's called the axis of symmetry. And so that point where the vertex is also the point where the axis of symmetry is. And I'll just draw one axis of symmetry here. And I'll do it on the one that's on the far right here. And so the axis of symmetry is basically the line, and I'll just use a dashed line here, that our graph is symmetrical around. Okay, so basically it's like this graph is, you're holding a mirror right down the center. And whatever you see on the left-hand side, you're going to see on the right-hand side, but it's going to be the reverse, right? Okay, so each one of these graphs has a axis of symmetry. And so vertex form allows us to quickly identify the vertex and the axis of symmetry. Okay, so what we need to be able to do is we need to be able to convert from standard form to vertex form. And the way we're going to do it is similar to when we solved using completing the square. But instead of doing something on both sides of an equation with a function, we can't really do that. So we have to do something on the same side, but something that won't change the equation. All right. It's going to change the look, but it's not going to change the value of the equation. So here we go. Let's see if we can do this. So we're going to convert these to vertex form. And this first one, so let's see here. If we want to convert this to vertex form, what we need to do is we need to complete the square. And the way we're going to complete the square is we are only going to worry about these two terms. And we're going to bring that 71 along. And we're going to add something to that 71. But you'll see. Let's just do this. Okay, so to complete the square, remember we add half of the coefficient of the x term squared. Well, when we did it for solving, we added it to both sides, but we can't add it to both sides here. So, but we don't want to really add anything to this equation. So what we have to do is we have to add it on this side, but then we also have to subtract it on this side. Okay, so here's what we're going to do. We're going to say, all right, f of x is equal to x squared plus 16x. Okay, and I'm going to give a little space here, and then I'm going to change colors. And I'm going to say, all right, I'm going to add half of 16 squared to both sides. So plus 8, well, I said both sides. I shouldn't say that. I'm going to add half of 8, or half of 16 squared, but then I don't want to change the value of the equation. So if I add something, I have to subtract it as well. All right, so then I'm going to subtract half of 16 squared. Okay, so what's going to happen is the two things in red essentially just cancel each other out. But we don't want to do that because we're going to be converting this thing to vertex form. So we want to now use this information that we have here to now rewrite this function. All right, and so what I'm going to do is kind of group this right here and then leave those other things off on their own. Now, if you remember from completing the square, if we have something like x squared plus 16x plus 8 squared, it's perfect squares on either end, right? So that means we can write this as f of x equals, and I'm going to get rid of the brackets now. We can write this as x plus 8 squared plus 71 minus 64, because 8 squared is 64. Okay, and then I can simplify 71 minus 64, so I can write this as f of x equals x plus 8 squared plus 7. And there we go. We have vertex form, because with vertex form, if you look up above, vertex form is right here. F of x equals a times x minus h squared plus k. All right, so those are just letters that mean numbers, right? So in this case, our a is 1 because there is no number in front of the parentheses, right? Our h, our h is actually -8. You might be wondering, why is it -8? Well, if you look at the vertex form, it's actually minus h, and we have plus 8, so that means it has to be -8. And then our k is +7. Okay, so now I don't say to do this on here, but man, it would not be a bad idea to get into the habit of identifying those three things when you convert to vertex form. A is 1, h is -8, and k is 7. Okay. All right. So that is converting to vertex form. So let's do another one here. And this one's going to look a little bit different, because in the first one we had a equal to 1. In the second one we have a not equal to 1. A is equal to 2. But with this one, we can factor that 2 out. And when we factor it out, we can't just get rid of it. We have to bring it along for the ride, right? And it's going to cause a little bit of a headache for us, but it's not bad. Not too bad. So here we go. I'm going to factor the 2 out. Okay, and I'm going to use a bracket here. Brackets, parentheses, they're just containers, right? So I'm going to use a bracket just to differentiate. So that means this is x squared. So if I factor 2 out of 24, that's minus 12x. And if I factor 2 out of 18, that's plus 9. Okay. So now I had to factor that 2 out so I can do exactly what I did to the first problem. I need to now convert what's inside the brackets to vertex form. And that 2 on the outside is just going to ride along until the very end, and then we're going to distribute that 2. And so you'll see it doesn't add too much complexity. It just makes it's something that's easy to forget to do. So I'm just going to remind you now, don't forget to bring that 2 along for the ride. All right, so here we go. So we're going to go f of x, well, that's not a pretty x, let's change that, equals 2 bracket. Now over here I did a bracket around that whole thing to differentiate it, but I've already used a bracket. If I do another bracket, it's going to look kind of goofy. So I'm going to use a parenthesis, because a parenthesis, a bracket, is just a container, right? So I'm going to say, all right, x squared minus 12x. All right, so now I need to add half of -12 squared to both sides. So I'm going to change colors again just because I can. So I'm going to add -6 squared. I need a parenthesis after that because remember I want to isolate that thing because you know where it's going. I'm going to turn it into a binomial squared. All right, and then I'm going to say, whoops, I don't need that. There we go, plus 9. So I don't want to forget that plus 9, but then here's where I have to now subtract that negative 6 squared. So I'm going to subtract negative 6 squared, and then I'm going to throw a bracket on there. Okay, so man, that looks kind of messy, right? But you can kind of see what's going on. The bracket kind of isolates the whole thing from the 2 because we factored the 2 out. And then the parentheses isolate the trinomial that we want to turn into that binomial squared, right? Okay, so if we just keep going here, we can say f of x equals 2 bracket parenthesis. This is where I can now, since I have a perfect square trinomial, I can write it as x minus 6 squared. And then I can say plus 9, and then minus 36. And then I'm going to put a bracket at the end. Okay, so you can see I just simplified my trinomial into a binomial squared, and then I simplified the negative 6 squared into 36. And you're thinking, wait a minute, it's negative 36? Well, it's not negative 36 because of the negative 6 squared. It's negative 36 because of the minus sign that's outside of those parentheses. All right, and then let's keep going. So here we go. We have 2 bracket. Nothing changes here in the beginning, but now we have to say 9 minus 36. Well, 9 minus 36 is negative 27. So we have minus 27. Okay, and now to get to vertex form, we don't want the brackets. We don't want the 2 on the outside like it is. We want to now distribute this 2. We're going to distribute it to that, and we're going to distribute it all the way to there, all right? So when we distribute the 2 to the binomial squared, we just are going to put it in front of the binomial squared. So we have 2 times x minus 6 squared, and then minus 2 times 27, or 54. Okay, and so you can see that even though it took a little bit more work with a couple of extra containers and whatnot, we now have a function that is in vertex form. And in this case, we have some different numbers. Instead of a being 1, we have a is equal to 2. We have h now is positive 6. You're probably, again, you're thinking, wait a minute, it says negative, it says minus 6. Isn't it negative? Nope. Remember, in the general form, or the vertex form, it's minus h. So if it's minus h, we always take the opposite of whatever number's in that binomial. That's kind of a trend, right? We do that a lot whenever we have a binomial. When we were solving, we would take the opposite of the number that's in the binomial. And then k, in this case, is negative 54. Okay, so there we go. We now know how to convert 2 different types of quadratic functions to vertex form. All right, that was just 2 examples. I think you guys can handle these. If you can't, you're going to have to email me and let me know, and then I'll help you out.